phase diagrams are the diagrams which shows the different phases of states of matter. So you're just keeping your thermal aside, that is the temperature aside. That means it is to say the temperature is said to be constant. The system also undergoes series of changes and again it comes back to its original position. That is all about the cyclic process, which can also be called as a reversible process. Hello everyone, I'm Rinda, Faculty of Physics from Vidhyaashram Pre-University College, Mysuru, welcoming you all to session 2 of chapter 12, and the chapter name is Thermodynamics. So, in the previous session, that is session 1, we studied regarding the introductory part of this chapter. So, in today's chapter, let us study concepts of this thermodynamics which comes within this thermodynamics. So first of all, we are getting into the first law of thermodynamics, wherein in our session 1 we had already studied the 0th law of thermodynamics. So what is this first law of thermodynamics and what does it say? That is the heat energy which is given to a system is equal to the sum of increase in internal energy as well as the external work done by the system. So here it is that we are looking into the heat energy which is given. So heat energy is nothing but dQ. It is given in terms of dQ. Q is the heat energy wherein the the change in the heat is given by D, the term called as D. So it is dQ, change in a heat energy when the work is done. So heat energy given to a system is equal to the sum of increase in the internal energy. So internal energy is represented by U. And it is D because there is increase in the internal energy. So increase means it is a changes which is taking place in the internal energy. That is why I gave it as D. So it is sum of du and dW because the work is done by the system. So it is positive and it is dW. So dQ is equal to du plus dW is the equation for the first law of thermodynamics, where dQ is heat supplied, du is internal energy, and dW is the work done by the system. So these are the components of first law of thermodynamics. So I hope you're clear with the 0th law, which says that A, that is the system A, is equal to system C, and the system B is also equal to system C. At that moment, we can say system A is equal to system B. So similarly, we have got our first law of thermodynamics after the 0th law, which says that the heat energy which is supplied is the sum of internal energy and the work done by the system. So we deal much about this first law of thermodynamics with the various applications as well as the various examples. Okay, so now let us move to the next part, that is we have phase diagrams. So what do we understand by this phase diagrams? Phase diagrams are the diagrams which shows the different phases of states of matter. For example, you had studied, here we have a phase diagram, okay, where we have got our solid state and a liquid state, that is our temperature. There is a temperature which is in y-axis. So we see the variation of the temperature. So how is its temperature variation? It's given like from 0. Here we have a component ice, that is a solid state of matter, wherein when there is increase in temperature, it reaches 100 degrees Celsius. So here this is one sort of a phase, and this is the boiling point of the water. Again, on increasing the temperature, this phase is called as a vapor phase. So we have got our liquid, that is how the states of matter changes. So this is with the help of a diagram called as phase diagram. Similarly, we have certain phase diagrams of pressure and volume, pressure and temperature. So here it is nothing but we have pressure with volume. When you have the variation of pressure and volume, here this condition can be told as isothermal condition. That means this is the one wherein we deal with the certain temperature to be a constant, because isothermal, to remember this isothermal, you can just remember like you're isolating and keeping it apart, that is temperature. So the temperature is kept apart and it is constant. Okay, so isothermal process wherein your temperature is said to be constant, so that is P as well as V variation takes place. So this can be told as PV phase diagram. Similarly, we have pressure and temperature which varies and volume at constant volume. So these are the phase diagrams which I had already discussed in our first session. So there is no much about these things. It is just that you have to understand what is meant by a phase diagram. So let us get into deep inside this. Let us see into the applications of first law of thermodynamics. How this first law of thermodynamics used. So it is dq is equal to du plus dw. So there is a lot of role of this heat energy which is supplied, and due to this heat energy, how the internal energy reacts and how the work is done. So here the family of this heat energy which is supplied, internal energy and the work done, these three concepts are having certain importance over here. So we have to find the relation. So what is that relationship between the specific heat capacities, that is Cp and Cv of the gas? So here we see the relation between the specific heat capacities. So here what do? We just consider 1 mole of a gas, heat it at constant volume, again take 1 mole of a gas, heat it at constant pressure. So what do we see? We just give importance to constant pressure and constant volume, and we supply heat to a substance, that is 1 mole of a gas is considered over here. So having those cases, if you just look into the relation, you will get it as Cp is equal to Cv plus R. Cp is equal to Cv plus R, which can also be written as Cp minus Cv is equal to R. So you can write this as, where Cp is specific heat capacity at constant pressure, and Cv is written as specific heat capacity at constant volume. And what is R? It is universal gas constant. So this is a relation for Cp and Cv, that is specific heat capacities at constant volume and temperature, and this is one of the application of first law of thermodynamics. So next let us move to isothermal process. So these are some of the applications of the first law of thermodynamics. So now we are dealing with isothermal process. What is meant by isothermal process? So as you all know, when I was discussing this phase diagram, I have told you isothermal. To keep in short, you're just removing, that is isolating temperature. Thermal means it is something which deals with heat and temperature. So isothermal. Okay, so you're just keeping your thermal aside, that is the temperature aside. That means it is to say the temperature is said to be constant. So we actually deal with few of the thermodynamic variables. So which are those? pressure, volume, temperature. So we have pressure, volume, temperature, and we are keeping isothermal, that is, we are considering isothermal to be temperature constant. So which are the one which varies? That is pressure and volume. Yes. So you can say the pressure as well as volume variations are there here, but keeping temperature constant. Okay. So what does it say? During isothermal process, the changes takes place in pressure and volume, but the temperature is said to be constant. So that is what this isothermal process says. So when the temperature is constant, you can just consider as T is said to be constant. When the temperature is constant, what happens to, according to the first law of thermodynamics, we have dq is equal to du plus dw, where if T is considered to be constant, then we can just give it as du, that is the internal energy is said to be 0. If the temperature is the constant one, there will be no internal energy within the system. So du is 0. So we have dq is equal to dw, that is amount of heat supplied is completely used for this work done by the system. Clear? So that is all about your isothermal process. Now let us move to adiabatic process. So we have adiabatic process. So what is this meant by adiabatic process? Here we have got, in adiabatic process, there is no constant as such. That is, there are variation in all three variables, that is pressure varies, volume varies and temperature varies, but the system here acts as an insulator. What is meant by insulator? Insulator means it is not affected by any of the surrounding system. It is just isolated. It is just for itself. It is not getting any sort of disturbance from other surroundings. Okay, so even the surrounding which lies next to it also doesn't disturb that system. Such kind of a system is a system which is said to be insulated. Okay, so here the same thing happens, because in adiabatic process usually we consider about insulated objects or insulated systems. So when that is the case, it is like the pressure variation is there, temperature variation is there and volume variation is there, but the heat which is applied over there, it neither enters nor it leaves the system. So that is all about your adiabatic process. If we have to consider a adiabatic process, we will have the same equation, dq is equal to du plus dw. So there are variation in pressure, volume and temperature. But here in this case, told you that heat is not allowed to go out nor it is allowed to come inside. So dq, that is the heat which is supplied, is said to be 0. If this is 0, then we'll have minus du is equal to dw. So this will be the equation according to the first law of thermodynamics for this adiabatic process. If we just represent the variables for isothermal process, the one which we had discussed last, that is isothermal process, we have pressure and volume is equal to constant, because temperature lies as constant, PV is equal to constant over there. But here there are variations for pressure volume, temperature volume and pressure temperature. So how is it given by this adiabatic process? It can be given as PV to the power of gamma is equal to constant. This is in case of pressure and volume. Next we have in case of temperature and volume. So temperature and volume is given as TV gamma minus 1. TV to the power of gamma minus 1 is equal to constant. And we have third one. So that is pressure to the power of gamma minus 1 and temperature to the power of gamma is equal to constant. So these are the three conditions under adiabatic process, because we have variations of all three variables. So what is this gamma? You might question, what is this gamma? So we have already studied that the gamma is nothing but is a ratio of specific heat capacity at constant pressure and constant volume. This is the equation for gamma. So this is all about the adiabatic process, and now let us move to cycling process. Cycling process is also called as a cyclic process. Okay, so here in a cyclic process, that is in a cycle process, what happens? You all have seen a cycle. Why it is called as a cycle? Because the wheels start turning, that is again and again it rotates. The one which rotates and get back to a initial position is always called as a cyclic process or a cycling process or just a cycle process. So how do you tell it as? In a cyclic process, the system undergo series of changes. It undergoes different changes. It undergoes series of changes and finally it returns to the original position. That is, for example, you can just take our Earth. It revolves around the sun and it takes 1 year to revolve around the sun. Okay, so it is 365 days what it takes to revolve around the sun, and when it revolves, it undergo all sort of seasons: summer, winter, rainy, autumn, spring. All this season it undergoes, correct? Once it completes its revolution, all these 365 days, again it starts from zero. That is, again the seasonal changes occur, like summer, winter, rain. All these things occur again and again. That is called as a cyclic process. Similarly, the system also undergoes series of changes and again it comes back to its original position. That is all about the cyclic process, which can also be called as a reversible process. So now next let us go to isochoric process. So what is meant by isochoric process? Isochoric process means here we keep volume to be constant. That is the main thing. Always we deal with the changes in pressure, temperature, volume, but the only logic what we have to know is which is constant at certain terms. If we know that, we will get to know the other which varies. So that will be easy for you to remember. So when you talk about isochoric process, you have to just remember that the volume is said to be constant. So what happens in this isochoric process? Isochoric process, here the changes takes place in pressure and temperature. The changes takes place in temperature and pressure. So at constant volume. So this is the thing, that is at constant volume, there is the changes which is taking place in pressure and temperature. So that is all about your isochoric process. So now let us see to isobaric process. What exactly is isobaric process? Here we usually see, till now we have seen constant volume, constant temperature, but now we are seeing into constant pressure. So at constant pressure, we have the changes taking place in temperature and volume. So if you know these concepts, it is very easy for you to understand what is meant by each and every terms: isothermal, isobaric, isochoric, and lastly it is adiabatic. So you will have to know for each and every terms used which are the constant, then it will be easy for you to answer the questions. So isobaric process, here the pressure is constant. So what is the variation? Where exactly the variation is taking place? It is in pressure as well as temperature. Next, let us go to reversible process. So we have reversible process and irreversible process, two types of process. So what is this meant by reversible process? So here if we just see to this reversible process, it is a one which can be made to go in a reverse direction, so that all changes occur in the direct process are exactly reversed. Okay, so whatever reverse it is occurring, that is whatever it is occurring in this manner, that is to initial to final, the same thing gets back to final to initial back again. So it reverses. So that is known as reversible process. Okay, so you can just take reversible process as day and night. Firstly, we start with day. Usually we consider day, afternoon and night, evening and night, and again back it is day, again afternoon, evening and night. It keeps on going. So this is the like day changes, day and night, how it changes. The same way, that can be a best example for you to understand regarding the reverse direction, and it is very simple concept. Okay, now after this, if we just get into irreversible process. So what is meant by irreversible process? Irreversible process is a process where there is no reversible actions which is taking place. For example, if you just give, here we have curdling of the milk. Okay, curdling of the milk is a general example for you to understand. Suppose if the milk become curds, can you get that curds back to milk? No. You can just get curds into a butter or ghee. Like that, you can just keep on moving forward, but it will never return backward. Your age cannot be a reversible process. It is a irreversible process. Never we can come to zero age. Clear? So that is all about your irreversible process and reversible process. But your behavior as your age passes can be a reversible process, because as we grow older and older, we act again kiddish, correct? So this is all about your very general topic for you. That is a very general example to understand what is meant by reversible process as well as irreversible process. So these are the concepts. So in today's class, we have studied about the first law of thermodynamics and its applications with a specific heat capacity Cp and Cv and all, and then we have studied regarding adiabatic process, isothermal process, isochoric process, isobaric process. So again, let us brush up what is meant by isothermal process. Isothermal process means you're just removing the temperature, that is the temperature is constant with pressure and volume to change. What is meant by isochoric process? Isochoric process, it's the volume which is kept constant, whereas your pressure and temperature changes. Isobaric process, here the pressure is said to be kept constant, wherein your temperature and volume changes. And adiabatic process, we have got pressure, temperature and volume, three to vary, but the heat is not allowed to get inside the system, or it is allowed to leave the system. So this is all about the concepts, that is the basic concepts which you have to know in order to study too deep inside this thermodynamic. Because thermodynamic, in our next session, that is session 3, we will be dealing with the Carnot cycle and the Carnot engine, as well as we will study about the second law of thermodynamics, which will be the end of this chapter. I hope you're clear with today's sessions, whatever we have studied. And that's all for today. Have a good day. Thank you.